In section 4.6, we're going to graph the other trigonometric functions, which really is cosecant, secant, tangent, and cotangent. Okay, so for the first one, we're going to graph cosecant, and we're going to use what we know about the graph of sine x to graph cosecant of x. Okay, first I'm going to scale my graph. I think I'm going to go by sixes to get to pi. So 1, 2, 3. Okay, I'm going to go ahead and put pi here. Your scale could be different, but I know this is going to fit. Okay, I am still going to split it into 4 so I can hit the 4 corners of the unit circle. And I am going to extend the negative because I want to see a couple periods of this graph. Okay, I'm going to graph y equals sine x with a dashed line, and I'm going to use that to figure out the graph of cosecant x. Once we graph this more, we will not graph sine x to get cosine x, but we will use the values. Okay, so if I was graphing sine, the sine of 0 is 0, the sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and then it goes back to 0. And then if I went in the negative direction, I would just follow the same pattern. I'm going to go ahead and make this a dashed line. Okay, now cosecant is the reciprocal of sine. So I'm going to use these key points to figure out what's happening on this graph. Okay, so first let me think about sine of 0. The sine of 0 is 0. The reciprocal of 0 is undefined. So everywhere I see a 0 on the sine graph, I'm going to end up with an asymptote. Okay, where's the next 0? Sine of pi is 0, so the reciprocal of 0 is undefined. 2 pi, asymptote. And once you start to see them, you can tell everywhere the sine is equal to 0, I'm going to have another asymptote. Okay, now I'm going to use some of the other nice points on the graph. Okay, let's see, the sine of pi over 2 is 1. The reciprocal of 1 is still 1, so this is still going to be on my graph. Okay, if I go to 3 pi over 2, the sine of 3 pi over 2 is -1. The reciprocal of -1 is still -1, so these points are going to be the same on my graph. Okay, now I'm going to consider 2 other points on the unit circle that I don't normally consider, just so you can see the shape of the graph. Once you have seen the shape of the graph, you're not really going to consider that anymore. Okay, I'm going to first consider pi over 6. Pi over 6, the sine of pi over 6 is 1/2. The reciprocal of 1/2 is 2, which means at pi over 6, which is here, cosecant is 2. Okay, now if I go to 5 pi over 6 in quadrant 2, the sine is still 1/2, so the reciprocal is still 2. Okay, so using those 3 points, the shape of cosecant between the asymptotes is going to actually look like this. Okay, now if I keep going, the sine of 7 pi over 6 is -1/2. If I do the reciprocal, it goes to -2. And the same is true on the other side. And I'm just using this to get the shape of the graph. Okay, so I'm going to continue to the left side of the y-axis. Because this is at -1, this is actually going to be the one that goes in the negative direction. And your points don't have to be exactly right, but that middle point, which is kind of like the vertex of the little parabola, should be right. So this is +1, which means this is going in the positive direction. And that would be a good enough graph for cosecant of x. Okay, I'm going to graph secant, and then I'm going to come back and look at the period, the range, and the asymptotes. Okay, I'm going to go ahead and graph cosine. I am going to scale it. I'm going to do the same scale. I'm going to go by 6. 1, 2. Okay, now that I kind of know the shape secant will make, it'll be similar to cosecant. I won't have to make as many points. So first, let me graph cosine with a dashed line. Okay, I'm going to divide 0 to 2 pi into 4. 1, 2, 3, 4. Okay, the cosine of 0 is 1. Then I go to 0, -1, back to 0, up to 1. Okay, I'm going to go in the negative direction too because I want you to see some cycles. Okay, now really, I would probably not do a dashed line on this, but I would probably plot the 0, the 1, and the -1, because because that's going to tell me the asymptotes. It's going to tell me whether each of the pieces of the graph are going in the positive or negative direction. So everywhere the cosine is equal to 0, the reciprocal of 0 is an undefined, so I'm going to get an asymptote. There's a 0, asymptote, 0, asymptote. Okay, now I'm going to consider whether the portions of the graph are positive or negative. Okay, so this is a positive one. This is going to open in the positive direction. And it doesn't have to be perfect. As long as that middle point's correct, you can just sketch it. This is at -1. This is going to open in the negative direction. We're just going to sketch it. This one's -1. It's going to open in the negative direction. And then if I go way over here, this would be +1. So this would kind of open in the positive direction. Okay, and it kind of makes the same pattern. Okay, now the period of sine and cosine are both 2 pi. Because of that, the period of cosecant and secant are also 2 pi. Okay, and if we look at the graph, let's look at cosecant. 0 to 2 pi, the cycle of the graph makes this up u and a down u, and it completes the up u, down u from 0 to 2 pi. Then it repeats and it repeats and it repeats. Okay, now let's look at the range. Range is the y value. Okay, well, it does go down forever. So in the y direction, it goes from -infinity to, and then where does it stop? It stops at -1 with a bracket. Okay, and that kind of takes account for that downward shaped u. But then there's more range because now I have the upward shaped u. The lowest point on those upward shaped u's is y is 1, and then it goes up from there. Okay, now the same is true with secant. On the downward shaped u's, -infinity to -1. On the upward shaped ones, it goes from 1 to infinity. If I had changed the fake amplitude, it would change the 1 to whatever the amplitude is. Okay, now for the asymptotes, I'm actually going to write an equation for all of the asymptotes. Okay, so first let me look at cosecant. I'm looking for the pattern first, and then I'll figure out where they are. Okay, there's x equals 0, x equals pi, x equals 2 pi, probably at x equals 3 pi, x equals 4 pi, and so on. Okay, so I want to express all the asymptotes. So I'm going to say x equals, let's see, it's at 1 pi, 2 pi, 3 pi, 4 pi, -5 pi. So I'm going to say it's at n pi, and n is an integer. Okay, so at 0 pi, 1 pi, 2 pi, -1 pi, -2, -3 pi. This includes all the asymptotes that exist for y equals cosecant x. Okay, now let's look at the graph of secant and try to express the asymptotes here. Okay, let's see. There's an asymptote at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Okay, and then once you kind of see the pattern, we're going to write an equation for the asymptotes. And I'm going to show you a couple ways to do it because some people like different ways. Okay, one way to do it would be to say, okay, there is an asymptote at pi over 2. Okay, and then there's 2 asymptotes per cycle. So every pi, I have another asymptote, and n is an integer in this case. If you don't write that, I'll still give you credit. I'll assume it's an integer. Okay, and then I'm going to think about this real quick. Pi over 2 plus 2 pi over 2 is 3 pi over 2. If I add 2 pi over 2, I get 5 pi over 2. Or if I subtract, I'm going to hit all the asymptotes. That's one way to express it. Some people like to think of it more about like what it sounds like. It's like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and the negative. So another way you might want to express it is some people say this. They say x is n pi over 2, but then you have to say that n is an odd integer then. Okay, that'll take care of 1 pi over 2, 3 pi over 2, but you don't want to include 2 pi over 2 because there's not an asymptote at 2 pi over 2. Okay, the last 2 functions we need to graph are tangent x and cotangent x, so we can kind of see what their parent function looks like and how we could figure this out if we had no idea. Okay, let me think. I'm going to space it. I still want to hit the 4 corners because they're still going to be useful. Let me make this, I'm going to make this pi. Okay, yours could be a little different, but we're going to see what this looks like first. Okay, I'm going to start with the corners, and then I'm going to need a little bit more information, but I can start off using these. Okay, what is tangent? Tangent is the y over the x. Okay, so at 0, 0 divided by 1 is 0. Okay, now I go to pi over 2. 1 divided by 0 is undefined. Okay, now I'm going to go to pi. 0 divided by -1 is back to 0. Down here, what is that? 0, -1. -1 divided by 0 is undefined again. Okay, and then I'm going to end up back at 2 pi. So I can see the pattern of asymptote 0, asymptote 0. And I can space it out just by hitting the 4 corners. Okay, now the problem is this is not my graph. There's more to my graph. So I need a couple other nice points to get my graph going. So in terms of tangent, okay, a place that has a nice tangent is right between 0 and pi over 2, because that's root 2 over 2, root 2 over 2. Okay, the tangent between 0 and pi over 2 is root 2 over 2 over root 2 over 2, which is 1. So between here and here, it's going to be positive 1. Okay, that's nice. Let me look at, no, let me keep going. Okay, and then I had an undefined, and then if I go to this point right here, that's negative root 2 over 2, positive root 2 over 2. So the tangent's going to be -1. So between this and this, I'm going to go down to -1. Okay, now let me go to quadrant 3. If I go here, between pi and 3 pi over 2, that's negative root 2 over 2, negative root 2 over 2. So that's going to go to positive 1. I have an asymptote, and then if I go to here, I'm going to go back to -1. Okay, I'm going to look at my points. Okay, I can see the graph now. Right where the tangent of pi is 0, this is letting me know it's going to go up on the right, and it's going to go down on the left. Even though I didn't finish near the origin, it's going up on the right, which means it is going to go down on the left. Tangent always goes up on one side, down on the other side. Since this is going down on the left, it's going to go up on the right. Okay, and I just want that 1 and the -1 to be in the right place. If I continued, it would have gone up on the right, down on the left. So this is the general shape for tangent of x. I'm going to do the same for cotangent, and now that I kind of know what it's going to look like, it'll go a little bit faster. Okay, let me think. I'm going to start with the 4 corners because that's going to give me the asymptotes and the zeros, and then I can work from there. Okay, so cotangent is x over y. So at 0, 1 divided by 0 is an asymptote. Okay, if I go up to pi over 2, 0 divided by 1 is 0. When I go to pi, -1 divided by 0 is asymptote. So I can already see 0, asymptote. If I went in the other direction, 0, asymptote. Okay, this is pretty good. I do know it's going to go up on one side and down on the other side, so I just need to figure out which side's going up and which side's going down. Okay, I'm going to use that same point I used up here. Okay, so between 0 and pi over 2, cotangent is x over y, so root 2 over 2 over root 2 over 2 is positive 1. So at pi over 4, I go to 1. Okay, now that I know the shape of the graph, that's enough information. Because I can see it's going to go up on this side, which means it must be going down on this side. I could check it. It's 3 pi over 4. It is negative on that side. But that's the shape it's going to make every time. So it's going up on the left. It's going down on the right. Up on the left. Down on the right. Great. So that's the shape of cotangent. Okay, now I'm going to go back and fill in the information about them. Okay, now I'm going to look at the period. The period is not the same as sine and cosine. I'm going to look at cotangent actually for the period. Okay, so for cotangent, one cycle of the graph is this weird downward slide. Okay, one downward slide fits between 0 and pi. So the period of cotangent is actually only pi. And then after pi, it repeats again and again. Okay, the period for tangent is also pi. Okay, this is always true unless there's some kind of period shift. Okay, so it's not the same as sine and cosine. Tangent and cotangent only have a period of pi. Okay, what's my range is negative infinity to infinity, because I can see it going down and up forever with no breaks in the middle. Okay, now I'm going to write a formula for my asymptotes, and I'm going to write a formula for my x-intercepts, so I'm including all of them, not excluding some of them. Okay, let's look at my asymptotes. On tangent, there's an asymptote at pi over 2, 3 pi over 2, 5 pi over 2. So that's very similar to the previous one. So there's a couple ways to write it. You're welcome to do it either way. I'm going to say x equals pi over 2, and then every pi n it repeats, and that's because the period is pi. N is an integer. And if you forget to write n as an integer, that's okay. I won't mark you down on that. Okay, I'm going to look at cotangent. The asymptotes are at 0, pi, 2 pi, etc. So it's a vertical asymptote. It has to be x equals pi n. N is an integer. And if you just write x equals n pi, I will assume that n is an integer. So that's okay with me. Okay, now I'm going to write a formula for the x-intercepts. Let's see, on tangent, there's an x-intercept at 0, 0, pi 0, 2 pi 0. Okay, so I'm going to say it's at n pi comma 0, and I'm going to say n is an integer. Okay, now on cotangent, there's an x-intercept at pi over 2, 0, 3 pi over 2, 0, and so on. Okay, so I'm going to say pi over 2 plus pi n. It's an x-intercept, so do make it an ordered pair. I am going to specify that n is an integer, but if you leave this off, I will assume that you're talking about n as an integer. Okay, now we're going to just do two graphs where we're adjusting maybe the period, there's a shift, there's an amplitude change, something like that. Okay, now let me see. For number 5, I'm going to graph y equals 3 secant of x plus pi over 4. Keep in mind secant is the reciprocal of cosine. So when I'm graphing this, I'm kind of thinking about cosine and what's happening to the cosine function. Okay, if I was graphing cosine, I'm not, but it's similar. The amplitude would be 3. Okay, so I'm going to keep that in mind when I do cosine. The period is actually 2 pi, and it's the same for secant and cosine because of this x. Let's see what's happening. This is doing a horizontal shift. So this is going left pi over 4, or if I set this equal to 0, I'm going to start my cycle at negative pi over 4. Okay. I'm going to set it up like I'm graphing cosine. Okay, since I'm going to go pi over 4, I'm going to space it by 4s. 1, 2, 3, 4. 1, 2, 3, 4. That's negative pi. Okay, now I'm going to think about graphing cosine, and then I'll fix it so it's secant. Okay, now when I graph cosine, cosine of 0 is 1, but the amplitude's 3. So I would normally be at 3, but I'm going to move it left pi over 4, so I'm going to move it over to here. And I know this is not secant, but I'm going to use it to graph secant. Okay, now the cosine of pi over 2 is 0, but I'm going to move left pi over 4. The cosine of pi is negative 1, but the amplitude's 3, but I'm going to move it left 1. 3 pi over 2 goes back to 0, but I'm going to move it left. 2 pi goes back up to the maximum, but I'm going to move it left. Okay, now I'm going to extend this a little bit with the pattern. So this was up, and then it went 0, and then it went down. This is up, so this goes back to 0, and then it would go back down. Okay, that's what cosine does. But secant is the reciprocal. So secant means everywhere I see a 0, I actually have an asymptote. Okay, and everywhere I see a maximum or a minimum, that's going to tell me whether those little U shapes are going up or down. Okay, so on this side, it's going up. Since this is negative, this must be going down. Up. And this one's going down, even though it gets a little bit cut off on the side. Okay, so that's a pretty good graph for 3 secant parentheses x plus pi over 4. Okay, now I'm going to look at the asymptotes and the range. Okay, where are the asymptotes? Okay, there's one here. What is this? This is 1, 2, 3, 4. That's at pi over 4. Okay, but there's 2 asymptotes per period. So every pi n, there's another asymptote. Okay, n is an integer. I'm going to assume that to be true, so I'm not going to bother writing it anymore. Okay, now my range, it goes to negative infinity, and then it goes to this point here, which is negative 3, and that's because of the amplitude change. Okay, and then for the upwards u, they start at y is 3, and then they open in the positive direction. Okay, now one last graph. This is 2 tangent x over 3. Okay, this is going to have what? It's not exactly an amplitude, but it's like an amplitude change, and it's going to have a period change. Okay, I'm going to think about that before I even start graphing it. Okay, so this is, normally the period for tangent is pi. Remember, not 2 pi, pi. Okay, so if I want the period, I'm going to do pi divided by 1/3. So I'm going to have a period of 3 pi, even though that's weird. Okay, now I'm going to go ahead and graph it like normal, and I'll take care of the period after. Okay, so normally what would I make this? I would make this pi. I would make this 2 pi. And I would make that negative 2 pi, but I don't want to do that. I want to fix it. Okay, so normally the period is pi. So instead of making this pi, I'm going to make this 3 pi. Instead of making this, if that's 3 pi, then this is 6 pi. Okay, I'm fixing the scale so I can make this work. But I'm going to pretend like I'm graphing it like normal. Okay, now I want to figure out what's going on. So this is 1, 0. So the tangent at 0 is normally 0. If I go up here, undefined, go down to here, 0, go down to here, undefined, and I can see the pattern. So I'm just going to continue the pattern. Okay, now I just need to make sure I know which side's going to go up and which side's going to go down, and I'm going to take into account the fact that there's an amplitude change. Okay, now at pi over 4, my tangent is 1, but because of the amplitude 2, instead of going up 1, I'm going to go up 2. So between 0 and this thing, I'm going to go up to the 2. That's how I'm going to show that there was an amplitude change. Okay, if it goes up on this side, then it must go down on this side, and it's going to go down to the negative 2. So now I know what the graph's going to look like everywhere. Up 2, down 2 on the left, up 2 on the right, down 2 on the left, and so on. Okay, this does respect my period. My period goes from 0 to 3 pi. It goes from the intercept to the intercept. Okay, now I'm going to have to write an equation representing the asymptotes and the intercepts. Okay, now I already got the period. Let me look for an asymptote, and then I'll try to figure out how to make it into an equation. So there's an asymptote right here. It's between the 0 and the 3 pi. So if it's between 0 and 3 pi, it must be at 3 pi over 2. Okay, now my graph repeats every period. Okay, because my period is 3 pi, if I add 3 pi n, I get where the next asymptote's going to be. Okay, now let me write an expression for the intercepts. Where are the intercepts? Let me look. There's one at 0, 0. There's one at 3 pi, 6 pi. Okay, so one way to write this would be to say it's 3 pi n, comma 0, where n is an integer. That's the cleanest way to write it. You might want to write it as there's one at 0, and then because the period is 3 pi, it repeats every 3 pi n, comma 0. And that's the same expression. And we are going to assume that n is an integer.